Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve axis symmetric case in code aster. And our geometry is pipe reducer is our geometry. This is actually an axis symmetric geometry. Instead of solving a full 3D geometry, we can take a small 2D geometry. We can solve it in axis symmetric case. So axis symmetric case is the simplifying our geometry into axis symmetric model. So this is my full geometry. I have taken a surface in XY plane. This has to be in XY plane, then only we can solve it. So XY means geometry has to be about the Y axis has to be revolved. That way it has to be there. Now I have taken and created this geometry and saved in step file. We'll import that step file. I saved in a step file in the same folder. So this is my file. We'll import this file and we'll use it for solving. So first I'm opening salome. We'll directly import that step file and we'll take that for solving. Next, so as a pipe reducer, the inside as a pressure of 1 megapascal and it is fixed in y direction. This much only the boundary condition, and it has made up of a steel of 210 megapascal and Poisson ratio is 0.3. Then density is not necessary for static analysis. Just go to geometry, file, import step file, navigate the folder, this one, pipe reducer. I have imported the file. After importing any file, first check the file dimension. So now we see this is about y axis, axis symmetric. By revolving you will get full 3D geometry. Just select this file, go to inspection, dimension, bounding box. So this is my dimension in meter, just close it. Now we'll create the groups to apply the boundary conditions. Create group, face group. Simply I just giving one face group. Inside edges I just want to apply a pressure. Press the shift and hold. Select the inside edges one by one. You can able to select all the edges continuously. Now just click add and name it as pressure. Just apply it. The second group is I just want to fix it in y direction. Here fix only y. Only a 2 degree of freedom it has. One is x direction and y direction degree of freedom. Okay. While solving axis symmetric model, this has to be in mind. Just apply it, just close. Now we have created the groups. Just save this file, just naming it to. Now we can move into meshing. This is actually a 2D case, NetGen 1D 2D, simple parameters 0.001 I am giving. We can go for very fine mesh also because it is very simple. Now see, along the thickness we have created 1, 2, 3, 4, 5 elements. This is enough to our model. Just save it. Now we can check the groups here. This is inside pressure group, and here I just want to apply fix in y direction. Now we can save this file and we can move into aster study to create the setup for axis symmetric model. Go to aster study. Now we'll check here in PPT. Here y direction is 0 and pressure is 1 megapascal. Just save OK. Instead of going for one by one, we can use wizard to generate the setup. There is option called isotropic linear elastic. Here we can create the setup mesh file. This is not 3D actually, this is axis symmetric case. Choose axis symmetric. Young's modulus, you can check it here, 210 gigapascal and Poisson ratio is 0.3 only. Here fix y, only y direction has to be fixed. Remaining don't specify anything. We need not to assign in y. If you want to assign also x, you can assign it, but x we should not arrest it. If you arrest x and y, you will get more stresses in that location. So only y direction we fix it. And another one is pressure. Choose the pressure group. This is actually 1 megapascal. We need to specify in Newton per meter square, 1 e power 6 Pascal. Now just save this file. Go to pictures, code aster, axis symmetric. Already result RMD is there, so give some other name. Result 1.RMD I am giving. Just save it, finish the setup. Now I have created the setup. The only thing is it will calculate only the primary variable of displacement. If you want to see stress and von Mises stress everything, we need to calculate from the result. Go to post processing, call champ. Here itself we can calculate. First constraint, from that we can calculate sigma L sigma node. Here we can calculate equivalent Elmo, equivalent node. Just apply. Here there is option called reuse. Choose the reuse. Just apply it. The same name, it will rename it here. Save OK. Small thing we need to update in output file. Just edit it here. Edit. Instead of choosing meca static, we need to choose call champ. Here tout champ, you make it S. Just OK. Just apply and save OK. Now we have created the setup. Now we can solve this model. Go to history view, make it plus, auto refresh, make it 5 seconds. If you want to change this, we can change it. This will not take much time, so just run it. So it is ask us to save the file, so you should save the file. Save this, run it. If any error comes, we have to modify our setup. We have to rerun again. Yes, it is solved without any error. Here you see diagnostic job is okay. Now we can go for post processing using paraview. Just open pictures, code aster, just apply it. Now we'll see the results one by one. First we check with the displacement. Here we are fixing in y direction. Here we are not fixing it, it is deforming more. The deformation is very less, as you can see. X direction you can check it, very minimum. It is allowable. Go here, von Mises stress, you check it. The von Mises stress coming around maximum of 17 megapascal. So here also you can check it by switching on the element also. So any one of the node you can check the value by placing here. For example, if you want to see the von Mises stress value in this particular node, here you can see result underscore SAEQ NOEU, that is the von Mises stress command. I mean equivalent stress command. In the first value is the von Mises stress, the second value is Tresca stress. Like that it will go. Displacement in that particular node is in, we have only a two displacement, one is x and y. First one is x displacement 5.33725 into 10 power minus 6. Y displacement is minus 4.4612 142 e power minus 6. That is a way we can check the value. Another way is go to view, Windows, there is an option called selection display inspector. The tool come here, choose any one of the value. Example, I am choosing a 1 meca stress. Now just select any one of the node. See, same way we can check it. The first value is a 1 meca stress. Second value is stress cost stress. Third value is principal 1, principal 2, principal, like that it will go. I'm just switching off here. Surface. To see the displacement, deformed shape, unselect the node. There is an option called generate vectors. Just apply it. Go to wrap by vectors. Give some scale factor. Just apply it. So this is the way it will get deformed. Now we can animate this also. There is an option called animation. Create a new animation track. Just OK. Now we can animate it. I have given scale factor very high. Now we can reduce the scale factor and we can run it also. So this is the way we can take the results and we can view the model. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.